Okay, so we have talked about figuring out the present value and future value of a single sum. And remember earlier in the videos, I talked about the fact that we can also use this same approach to figure out the future value and present value of annuities. Now, first off, we want to kind of define what an annuity is. And these three it fulfills these three requirements. So it has to be periodic payments, so more than one payment. And they're usually called rents. Even though it's not rent, they'll call them rents, each of these payments. So periodic payments or receipts of payments called rents of the same amount. So they're equal amounts. 10,000, 10,000, 10,000, 10,000, 5,000, 5,000, 5,000, 5,000. They're not different amounts. They're not 10,000, 5,000, 7,000, 2,000. They are all the same amount. There has to also be the same length interval between each of these payments. So maybe that's once a month, maybe that's twice a year, maybe that's once a year, maybe it's quarterly, but it always has to be the same length of period of time between them. So it's not 1 month and then a quarter of a year and then another month and then 6 months. They have to be equal intervals in between. And the interest has to compound during each interval. So there's no simple interest with regard to present value and future value of annuities. It's going to be compounded once each interval. And remember, I talked as well very briefly about the difference between an ordinary annuity and an annuity due. So an ordinary annuity, this is where those payments occur at the end of each period. So if it's at the end of the month, it's the last day of every single month. And it covers the period before the annuity payment. So you think about like utility payments, the utility payments that are on budget billing. So you're paying for utilities you've already used. So it covers the prior period, and your payment is due at the end of that period. That would be like an ordinary annuity. An annuity due is where the payments occur at the beginning of each period. So a good example of that actually is rent payments. Usually they're due at the first of the month, and it covers that month. So that if you leave in the middle of the month, you are due a refund for the remainder of the month. But that would be an example of an annuity due where those payments occur at the beginning of each period. And remember, how I keep them straight is D comes before O. So the annuity due is at the beginning of the period. The ordinary annuity is at the end of the period. That's just how I keep all of that straight. So the first one we're going to talk about is the future value of an ordinary annuity. So these are the payments that happen at the end of the period. So there's no interest during the first period here, no interest during this period. And so if we can figure out the present value or the future value, what we're going to do is figure out the future value. So in this example, we've got 8 payments of an annuity due. We don't know what the interest rate is, but they're $20,000 payments each. So we would have to figure out what the interest rate is on those payments. But this is just sort of a timeline to give you an example of what that ordinary annuity due looks like, where those payments are coming at the end of that period. So let's look at an illustration here. We've got, so let's assume that $1 is deposited at the end of each of 5 years. So this is an ordinary annuity. It earns 5% interest compounded annually. So following this computation of the future value, we would use the future value. We can use the future value of one table. What we would do is have 5 different calculations and 5 different factors that we would then add up to figure out what the value is of that those $5 of payments over those years. So for example, we would have one payment where we make one payment of $1 at the end of the first year, and what that payment would be worth at the end of year 5, and then another payment at the end of year 2, and calculate what that payment would be, and so on and so forth. This is a really long and cumbersome way to do it, because what you're doing here is for every period, you are adding up, you're doing the calculations separately, and then adding them all up to figure out what the value is at the end of that period. We have an easier way of doing that. We have a table that we can reference to make those calculations. So again, if you're into formulas, here's your formula. This is the formula that we can use to calculate the future value of an ordinary annuity of 1, the 1 being one single payment amount. So this is what it would look like. And again, what we're looking for is our future value factor. We're looking for a factor that's in those tables. So that's what we're looking up. And once we have that factor, then we will use it to multiply our annuity amount by. So this calculation, R is the periodic rents. So whatever that payment is every period. This FVFOA is the future value factor of an ordinary annuity. So what we're going to multiply our rents by to figure out what the future value of all those payments is. I, again, is the interest rate, N is the number of compounding periods. So you can use this equation to figure out the factor to use to multiply the rents by, or you can use the tables. The tables, of course, are quite a bit easier to use. Okay, so let's look at an example. And actually, let me pause here for just a moment. I'm going to pull out my table and show you the future value table of an ordinary annuity. Just a moment. Okay, so this is what the table looks like. And this is, you can see right up to the top. So here's table 6-3, future value of an ordinary annuity of 1. Again, ordinary annuity, these are payments that come at the end of the period. So again, we have our periods of time down here, number of compounding periods. Again, these aren't years unless the compounding period is a year, but this is the number of compounding periods, and then all of our interest rates are up at the top. I have 2 pages of this. So here's the second on the other side then. But the same information, is just we've got different interest rates that go along the top. So that's what you're going to be looking at once I post these tables. All right, so continuing on, let's look at this illustration now, because we'll use the tables so I can show you step by step how this works. So what is the future value of $5,000 deposits made at the end? So there's our ordinary annuity, the end of each of the next 5 years, earning interest of 6%. All right, so let's take a look here and see if we can't calculate this out using our table. Let's look at our factors here. So we've got 5 payments of $5,000. This is an ordinary annuity, and we want to know the future value, right? So 5 payments, $5,000, the interest rate is 6%. So let's figure out what the factor is using our table. These payments are made, so they're five payments compounded each time. So we'll look at the number of periods, 5, and then we'll look over at the 6% column, and we get a future value factor of 5.63709. We're going to take that 5.63709, and we're going to multiply it by our annuity amount, a single annuity payment, 5,000. Let's get our calculator out here. Okay, so we got 5.63709 times 5,000, and we get 28,185.45. Okay, 28,000. So 5 payments made at the end of each period. There are 5 periods. Interest is compounded each period. 6% interest, $5,000 payments. At the future value of those payments is $28,185.45. So if let's look at a real life example of something like this. If we are saving money, let's say we can save $5,000 every year. We can set aside $5,000. We're going to make that payment at the end of the year. We're going to deposit the money, and we can get 6% interest on that money. We will, at the end of 5 periods at 6%, we will have $28,185.45. So if we look at the slide, so they used the equation here to come up with the factor, 5.63709. We used the table to come up with that factor, 28,185. So using the table, we already saw which table that we would use. We're going to use that future value of an ordinary annuity table, which is right here, 6-3, future value of an ordinary annuity. And we're going to use the table to find it. We found it 5 periods, 6%, 5.63709 is what we came up with for $28,185.45. So that's the future value of an ordinary annuity. So let's look at another example here. Okay, so we've got Hightown Electronics. They deposit $75,000 at the end of each 6-month period for the next 3 years. All right, so $75,000, 6-month period, 3 years, to accumulate enough money to meet debts that mature in 3 years. What's the future value if the annual interest rate is 10%? Okay, so now we've got an added little complication here. Remember, we still have to multiply our compounding periods by the number of times that the compounding happens in a month, and we have to divide our interest rate by the number of compounding periods. So let's take a look here what we got. Okay, so I kind of wrote those basics down. $75,000, 6 months, over 3 years, 10% annual. Okay, so to figure this out though, what we need to do, because there are 2 compounding periods per year. So we're going to have to take, we have 3 years, 3 times 2 equals 6 periods. And then we've got to take our 10% divided by 2 to get 5%. So if we do that, we got 75,000. So let's look, we have 6 periods. Here's 6 at 5%. 5%, we get a future value factor of 6.80191. All right, now what we'll do is take that 6.80191, multiply that by 75,000. Those are our payments. We'll need the calculator for that one. Oops. So times 6.80191 is 510,143.25, which means at the end of that period, now they put a 74 here. Gosh. At the end, sorry, you're not looking at what I'm looking at. Okay. You see they made a mistake here. That should be a 75,000 right there. They got 74. So that means that with these 6 payments, at the end of these periods, they will have accumulated $510,143.25. So let's see. Take a look here. All right. 5%, 6 periods. Again, 6 periods. 5%, 6.80. Here we go. Multiply it by that factor. 510, 143, 25. Why, looky there. That's what we've got too. 510, 143, 25. Okay, so we're just doing the same thing. So this is an ordinary annuity. Okay, so this is the future value of an ordinary annuity. When in the next slide, we're going to talk about the calculating the future value of an annuity due.